Hello, and welcome to Algebra Unit 4-2, Lesson 2. Today's objectives are that scholars will apply square root functions to real-world situations. Okay? So the first thing we look at is something called the ride. So, two plans are being considered to determine the speed of a theme park ride that has a circular wall that spins. Plan A, which is right here, is represented by the function with the graph shown. The ride shown in the photo is an example of Plan B. If the ride has a radius of 3 meters, which plan would result in a greater speed for the ride? Okay, so we have Plan A and Plan B. So over here I have Plan A. When the radius is 3 meters, the speed is about 6 meters per second. Okay. Plan B, over here, tells me that we have the function f of r equals 5 times the square root of r, where r is the radius of the ride. So in this case, we know that our radius is 3, so f of r is 5 times the square root of 3. Well, what is the square root of 3? In this case, you are really just going to go to Desmos or use any calculator to get an approximation of the square root of 3. So if you put the square root of 3 into a calculator, and you're going to round this to about 3 decimal places, so I have 5 times 1.732, which if I multiply times 5 gives me 8.66 when I round it. So in this case, which plan gave the greater speed? Plan B gave the greater speed. And now, of course, we're evaluating this at only 1 point. So let's look at what happens when we evaluate different functions at different points. So here I have two different functions, function A and function B, that we're going to evaluate the function and give the value to the nearest thousandth. One very important thing here is that you do not want to do any rounding until you get to the end. So over here, let's start with A. I have v of x equals the square root of 17 divided by 10. So I am literally going to put that into my calculator. I'm going to do the square root of 17 equals and then divide by 10. And if I round that to the nearest hundredth, I get thousandth, sorry, so we're doing 3 decimal places, equals 0.412, and then my next number is a 3, so I'm just going to cut it off there. So we have tenths, hundredths, thousandths. Now let's come over here to function B. In this case, I have w of x equals the square root of 17 over 10. Now, in this case, we're going to need to make sure that when we put this in our calculator, it should look like this. Square root of, and then in parentheses, 17 divided by 10. But that should all be in parentheses. So make sure that when you're putting that in your calculator, you do that correctly. Square root of 17 divided by 10. And in that case, it gives me 1.30. It says 3038, but remember, since we're rounding the nearest thousandth, it'll be 304. So notice, as similar as these look, we get very different answers. So please make sure that you're watching when to do your square roots and when not to. So this one, when I put in the calculator, it's like this. Square root of 17 divided by 10. Whereas this one looks like this. So please watch that, but you need to make sure that you know how to put those into your calculator. Nice, easy evaluation. So now let's talk about what you're going to be doing for your classwork. So this is your classwork assignment. Who wins the race? So Alice and Bianca each participate in a 5-kilometer race. Alice's distance covered in kilometers. So her distance, in that case, this is her distance. And T is the minutes. Is A of T equals T over 4. Bianca's progress can be modeled by B of T. And again, this is her distance. And this is what gives us our answer. 2 times the time minus 1, and then all of that square root. So you're going to answer these 3 questions. Who starts first? Well, what does that mean? That means I'm looking at my graph, and I would actually put this into Desmos. I put both these into Desmos. Figure out who starts running first, who leaves there first. Who gets to the finish line first? Remember, they each need to travel 5 kilometers. It's a 5-kilometer race. Who travels 5 kilometers first? And at what time or times, notice it could be one or the other, during the race are they side by side? That means where are they at the same point? And you're going to explain how you got that. You can insert Desmos graphs, whatever you want to, in order to answer this question. This is what you're doing in order to make sure that you understand this work. So please make sure that you put this into Desmos and that you really think through and explain. Remember, we have explain next to all of these. I need to see some good explanations. If you have any questions, you all know how to contact me.